Hello and welcome. On this video, I'll try to make use of my equipment and analyze some commonly found items for a variety of analytes. Because it was set up this way when I started this video, and also because I struggled to find the right concentration of mobile phase in the programming, I'll start with the anion in water samples, which is easier. But first, I replaced my autosampler with a more appropriate one, as the older did not inject sample correctly. It was not suited for ion analysis. I've also installed this new valve, which injects the samples to be analyzed in a very consistent and reproducible way. Now the sample goes into these plastic vials, which is protected by a filtered cap. Each one of the samples is then lined up for injection according to the sequence set up in the computer program. Before I go any further, let me clarify one thing. I have seen many people using TDS meters with little or no understanding of their functionality. These are conductivity detector that measures the water electric resistivity between two prongs and mathematically invert the results. Pure water has a resistance at 1 centimeter of about 18 mega ohm, and 1 over 18 million is 0.055 microsiemens. Although very helpful in the field, they give a good idea of the ionic concentration of both cations and anion combined, but they cannot measure any organic or biological contaminations. Therefore, it cannot determine the water sample is safe to drink or not. Although it uses the same technology, the ion chromatograph takes it a step further as both a qualitative and quantitative analytical instrument. All right, so everything has been programmed and it's all ready to go. The computer is handling everything. There's nothing else for me to do, so I can just go out and do something else and review the data when I come back. And since we are waiting, here's a quick intermission. Enjoy. After a successful calibration with a correlation coefficient above 99.9% for all anions, I can reliably quantify them from 0.5 to 10 ppm, except nitrate. Nitrate just does not calibrate above 5 ppm. We had the exact same problems when working at my previous job. To begin with, here is the deionized water I've been using. The ripples here are due to impurities in the mobile phase, but do not interfere with any analytes in any way. As you can see, if there's any anions left in this water, it is below or much below my detection limit. I also have to do an MDL study to see how low I can detect anything. Now, I wanted to check again my tap water before and after the filter. So here it is straight out of the tap, and the values in ppm are here under amount. Most notably sulfate at 32 ppm, unsurprisingly chloride at 12.7 ppm, unexpected phosphate at 1 ppm, and 0.6 of fluoride with 1.7 of nitrate. Now after filtration, the results are lower, but just barely. To be fair, this filter is about 50% consumed and is designed for cations, so it's not too much of a surprise. The software allows to overlay the chromatogram so we can easily compare them. Next, here is 3 popular brands of drinking bottled water. They are more or less the same, Absolpure being the least pure of the 3 I've tested, and the purified water is actually very much purified. They are not kidding here. I was stunned to find a brand of water advertising a high pH. I couldn't resist to taste it and test it. Lots of chloride, as you can see. The peak is distorted because of the high carbonate concentration. If you remember earlier, carbonates are part of the mobile phase. There is a small creek running through my neighborhood, and I thought it would be interesting to check the pollution for anions. So I grabbed a sample for analysis, and since it snowed again, I picked up another 3 weeks later, hoping to see an increase in chloride due to road salt runoffs. I apologize for the glare. It does get sunny in Michigan sometimes. Because of the large amount of chloride, I ran them at 100 dilution and noticed some increase in chloride as expected. The sulfates are naturally everywhere and could come from zeolites, construction material, decaying organic matter, and concrete. Now for cation analysis, I have to replace the guard column, the analytical column, and the suppressor. I use a weak solution of methane sulfonic acid for the cation's mobile phase. And after finding a concentration that would work, setting up a new program, identifying all the peaks, and calibrate again, I can identify and measure concentrations. Whoa. I'm sorry, but I can't do any more of the analysis I was planning to do because there is still work to be done and undelivered mail with parts I need for this. I apologize, but I have no choice to ask for your patience and understanding in these times, as the USPS is less reliable as it usually isn't. So please forgive me, but the next video should have what you and I are looking for to complete this analysis. Now, don't worry, I didn't let you down before and I won't let you down this time. In the meantime, this is a great opportunity for you to let me know what you wish to see me analyze and what you think about all of this. I mean, why not? You know? Right? Well, I should probably point out that drinking alkaline water is not recommended on a daily basis, and one should consult with a medical professional before doing so. There's a lot of fabulous, unproven, unscientific claim about drinking alkaline water, and you should definitely do your research. So, I hope you enjoyed this video and found it interesting. As usual for every YouTube video, thumbs up, subscribe, bell, Patreon, you know the drill. So thanks for watching, and I will see you on the next one. And again, I'm really sorry about this.
Damn it!